Hey everyone, my name is Marcus. I work developer relations for Edge and Node building the graph, and I'm super excited to go into today's workshop that's going to be going over 4 best practices with subgraph and really subgraph development that can speed up indexing and querying. So before we get into going into those 4 best practices, I want to go through a quick announcement. Right now, there is a sunrise going on in the graph ecosystem where there is a cutoff date of June 12th where the hosted service is eventually going to be going away. And that means if you have a subgraph on the hosted service, upgrade to the graph network. And with that upgrade process, there is 4 million GRT available to reward your upgrade process, as well as if you do any of these certain missions. So what I'll do is go ahead and share my screen briefly here and just go through the different details about the Sunrise Upgrade program. We have June 12th as the cutoff date for this. If you enroll in the Sunrise Upgrade program and upgrade to the Graph Network by June 12th, as well as participate in these missions that you will see in here, especially the builder track, there's a good amount of GRT in here. If you simply complete these tracks here, the Web3 builder track, about upgrading subgraphs, coding and querying, building a repo, and then also just simply querying subgraphs that are on the Graph Network can get you GRT and get you live on the Graph Network, which is very exciting. So with that all being said, that is it for the announcements today. Let's go into the workshop today. This is Subgraph Best Practices, how to optimize indexing and querying speed. So what I want to do also is highlight the Graph Builders newsletter. If anyone here is interested in building on the graph, I write this newsletter every single month to summarize all of the news that pertains specifically to builders, such as new updates, new features, and this is the QR code for that. So what I will do is say that is everything for the announcements. Let's get into it. So success is the sum of small efforts repeated day in and day out. Robert Collier, who's an author. Little simple quote here, but I do like it because essentially when we are optimizing anything, we're trying to find a little bit more success. Small efforts all the time. And that's really what optimization is about. The sum of small efforts adds up to a lot. And we're going to go through 4 of those efforts that are relatively simple that can provide a lot of returns. So really quick review on subgraph and how it is shaped. There's going to be a database, and in that PostgreSQL database, we've got the graph node, and that's talking to data consumers, all through GraphQL as the query interface. So this database right here, if it ever expands greatly, essentially graph node has to do more work, and that is having to go through a larger database. And we're going to see that theme come up regularly in this optimization talk. If we can keep this database of manageable size in the subgraph, that makes a big difference. Now also, not only subgraph database size, but subgraph processing. We already talked about this database, making sure that database is small as reasonable, as optimized as possible. And then also we're looking at this entire workflow. Essentially, how quick can this occur? How quick can this entire workflow of a subgraph go? And how can we optimize that? And so those are 2 themes that we're going to go back to regularly in this presentation. So the first best practice that was brought to the attention of myself and many other developers within the Edge and Node team, this is a relatively new feature, pruning with indexerHints. Now, in terms of what this means, let's go into it because this is a relatively new feature. And for those of you who have older subgraphs might not know about this one, let's see what happens when we have best practice 1, pruning with indexerHints. Essentially, we have happy DApp users because we get faster query response times, and happy indexers because with pruning our subgraphs database, it's a smaller database, and it's easier to go through that data that's in the database, easier to retrieve the data. It just is faster. It's just much, much faster with the query response time with that smaller subgraph database. Now, what does this look like? How do we actually integrate pruning with our subgraphs? Sometimes there's an older subgraph out there. That's okay before spec version 1.0.0. Our spec version has to be at version 1.0.0 for this to work because it's a more recent update. But once you've upgraded your spec version, dropping in indexerHints into your subgraph.yaml is the way to go ahead and prune automatically. And there's a few different settings for prune, and we'll go over those in a little bit here. But really what I want to say is this is actually quite a big deal because I've seen members of GraphNode at times and team members saying there's some subgraphs with way too many entities that are never being queried, and it's just weighing down the subgraph to the place where it's just having issues. And with a simple 2 lines of code here, the person who's developing that subgraph can really greatly change their query performance just by having it more optimally built. So here's another option for Prune. For pruning, if we want to have a certain number of blocks to retain, just to have that data and be accurate with that, let's say we want to have 6 months of blocks always stored, but anything past 6 months we don't necessarily care about. We can do the math and see how many blocks 6 months is, and then from there, go ahead and put that number in there and always have that, or a week, or 2 weeks, or a year, whatever it is. It's just making that number clear in terms of what we are desiring in our subgraph is really going to improve our experience with responsiveness. And the last option here is prune never. So this is used when we want all data and the subgraphs database to be quite full with every bit of data that has been emitted through the either through an event or an ETH call. And from there, we have that in our subgraph, and it's never going to be pruned, ever. So those are the 3 options. It's either auto or put a specific number, or never. And real quick review of auto, in terms of the specifics on that, that number is dictated by the indexer themselves. So that's going to have to be something that I'm not entirely, and this is actually a good point. The GraphNode team, I just confirmed with them today, they are going to be coming on for another session of this this presentation about the best practices 1 through 4 and talk more in detail about kind of how they built it, why they built it. My job is just to explain that this is available to everyone out there. So don't worry if you want more detail about Prune Auto, that's coming as well. So let's go into considerations before pruning. Of course, when we are taking our database and making it a little bit smaller, we have to think, okay, well, what could this be affecting? Are we using time travel queries? We can't query what's been pruned. If we've deleted that from our database, it's gone. So ideally, it would be best to use prune number of blocks to retain, so we have the exact number of weeks or months that we would like, or prune just never, and just always have that to be able to use time travel queries. Are we grafting? If we want to graft to a block height that has been pruned, that's not possible. So it's best to use prune a number of blocks to retain once again, or prune never. Those are the 2 good considerations to make before pruning. So with that new feature, go ahead and try using indexerHints. It's actually deployed automatically with every new CLI deployment. So upgrade your CLI and get playing with that one. So let's go into subgraph best practice number 2. This is use derived from to manage arrays. So using derived from is a pretty solid technique to manage relationships, and this is what results if you use derived from. Once again, we get happy DApp users. There's going to be faster query response times, and also there's faster indexing speed. There's going to be faster processing of that data too. So we're smaller subgraph database size, and then also processing can be faster if we're using derived from. We also, once again, have happy indexers, smaller subgraph database, and faster processing, easier to store and retrieve data. So what does this look like? Well, this is a potentially troublesome array that is not using derived from. We have a post here that potentially could have an infinite amount of comments. And if we use this type of relationship here, this one-to-many, we have a potentially infinite double storage of comments, because it's going to be stored, this comment will be stored in the actual entity that is a comment, and then also it'll be stored in the field comments in an array. So we double store, and that really becomes an issue and just can cause a lot of bloat if we're double storing data in our subgraphs database. So this right here is a proper use of derived from, where, as we can see here, we once again store all of the comments here, but we're deriving these comments from this field post, which refers back to here, and we have a basic loop going on right now to have this link up. But essentially, this only stores this data once. We don't double store it if we use this technique, and this literally can take an entity size and chop it in half, which is a big deal whenever we are dealing with crazy amounts of data that potentially have millions of entities. That's a really large deal. So once again, faster processing too, just because there's just less data to go through. There are even more advantages with using derived from whenever we are linking entities. We can query the post and see all of its comments. That's just good one-to-many, but that's also reverse lookups also are brought up. Query a comment to see which a post it comes from. That's also just one-to-many, but this is the real unique one, the derived field loaders. Directly access and manipulate data from virtual relationships in the mapping. So essentially we have a relationship here, and we don't necessarily see the relationship, but it's a virtual relationship. If we want to actually access this virtual relationship, we can do so with derived field loaders and go ahead and play with that data in the mapping. So there is information of that in a repo out there, and I will put that in the comments when I am able to get that in here. But yes, we will be putting that in the docs very soon too. We do have derived field loaders, which is pretty cool. So those are so far two best practices of subgraph development. Another, before we go into that, this is a fantastic blog from DevRel Kevin Jones that goes into more detail about managing arrays, because arrays can be potentially problematic if they get out of hand. Go through this one if you want to go into more of a deep dive into how to manage arrays and subgraphs, really understand what they can do to your subgraph and just optimize it, and a few other techniques in this blog. Great blog. Go ahead and find it on thegraph.com blog. So next, this is best practice number 3, and this is a big one. Use bytes as IDs and immutable entities. These are basically a 2-for-1 best practice, and these have shown some significant performance increase in terms of percentages that we'll talk over too. Results of using bytes as IDs and immutable entities. We have, once again, happy DApp users and happy indexers. Faster indexing speed, nearly a 50% improvement in indexing speed with bytes as IDs and immutable entities. That is crazy jump in indexing speed. And then also query responsiveness, just over 25% improvement in just over 25% improvement in query responsiveness. So that's a big deal to have, just with these little changes, a huge jump in indexing speed and query responsiveness. So go ahead and make these changes if you do not have bytes as IDs and immutable entities. We'll go into what those are in just a second. And then finally, of course, we have happy indexers, smaller subgraph database, and faster processing. With both of these, easier to store and retrieve data. So this is a problematic entity. We have an entity that is not an immutable entity, as we do not see immutable on the entity. And the ID is of the type ID. It could also be of type string, and also, I believe, int8, I believe, or I think there's a few different ones that could be possible. The best one is bytes. And the reason for this is just simply we just have faster processing, because bytes is a lower level language. We don't have to actually go ahead and have more compute on a string on top of that. So this is much better. This is an entity that is immutable, and this is a ID that is byte. So very quick changes here. And there's some considerations when making an entity immutable and making an ID bytes. The first consideration is, well, what is a mutable entity? Basically, it's an entity that we do not plan to change in further versionings of our subgraph. And a good entity to make immutable is simply an entity that is logging event data without any transformations. That means we're just simply taking the event from chain and bringing it right into our subgraphs database, and we're not going to be taking time and effort to change those entities' kind of shapes. And that's just saying, hey, we won't change this in the future. This is the way it's going to be, and that's it. So that's a good candidate for an immutable entity. There's other reasons to use immutable entities, but essentially the second we make it immutable on further versionings, we won't be able to change it. So that's okay. The next one here is ID of bytes, and there's little considerations that we have to make with that if we have IDs of other kinds, such as string. Let's go into those considerations. The first one that we need to do is if we are going to pass the ID into an entity, it's best if we're going to be making a random entity or somewhat random entity's ID of the type of bytes. We use this concat I32 to concatenate two different pieces of data. And if we just use that, it results in a bytes object that we can go ahead and use as our ID. Now, having this little feature right here that is part of GraphTS is quite helpful. Being able to concatenate is also helpful. You don't have to use it. You can just go ahead and use the event transaction hash. But concatenation for an ID is even better if possible because it creates such a unique ID that it is very unique to that entity itself. So that is a consideration to transition over to bytes as IDs. If you're using a string here and other different styles of concatenation, this is the way to result in a bytes object. Another consideration is sorting. So if we want to go ahead and query the transfers entity, and we want ID from, to, and value, and we sort an order by ID, it's not necessarily going to be in order. As we see here, if we sort by ID, as it is in a bytes, it's this format here, and we're getting kind of an odd return on the data. It's not going to be sequential if we want to sort by ID. If we would like to do that, there's something that we can do as a technique. We could simply just add in a big int, and somewhere in our entity, this one I just added a big int in the database as a token ID. That is a big int, and just simply made it a counter. And so anytime a new entity was created, it was 1, 2, or 3, and very easy to do that. So if you would like to have some organization with your bytes as IDs, go ahead and have a counter in there in some way to have sequential order. That is quite helpful in your sorting. So some considerations as bytes as IDs. There's a few other reasons to not use bytes as IDs as immutable entities. Number one, human readable IDs are needed. Let's say we want IDs for whatever reason to be human readable. Then string is the way to go. ID is the way to go. Integrating your subgraphs data with another model's data that does not use bytes as IDs. So if we have data's from different locations all trying to come together, that. And then finally, performance improvements are not desired. If you're okay with just hacking around and poking around, you don't need to. But if you are eventually planning to publish to the graph network and want a production-ready subgraph, it's best, if possible, to use bytes as IDs and immutable entities wherever possible. Also, if there's any questions about this at any time, feel free to launch them into chat. I will go. There'll be a Q&A at the end for anybody who has a question about this. So let's go in to this blog here. This was written a little while ago by David Luttercourt. He is a graph node developer. 2 simple subgraph performance improvements. He goes into using bytes as IDs and immutable entities at length and does tests and has data on comparing using bytes as IDs and immutable entities versus not using bytes as IDs and immutable entities. So that's something to take a look at if you want to dive in a little bit further into this concept of why it's a best practice. So finally, best practice number 4, ideally, we avoid ETH calls. Now, really quickly, we went over this in the beginning on high-level overview of data processing. Without this ETH node right here, let's just delete this. Let's just say this isn't here. All right, that's gone. This is how a subgraph processes data. All right, but then if we add in a ETH call, we have to make that call to an ETH node and to an Ethereum node, and that potentially can take, maybe 100 milliseconds all the way up to a few seconds, and that can really slow down subgraphs indexing. Where if we're going to be making ETH calls and there's a lot of them, or even just a few of them, it can really add in processing time and also just waiting, just the runtime overhead just adds up. So we don't like that. So what do we do about this? Well, ideally, we go ahead, if we avoid ETH calls, that's great. There's happy DApp users. we have faster indexing speed. We don't have to wait for that Ethereum node to return that call. And happy index or subgraph indexing speed is optimized. We're really more likely to stay at chain head if we can avoid using those ETH calls. Now, how do we identify if our subgraph or if a subgraph out there is using an ETH call? Go ahead and look for bind. That string right there, bind, anywhere in the code indicates that there is a ETH call that is following that bind. And we can see that right here, where this instance right here was created by binding to the event address. And then from there, we're able to go ahead and call that ETH call right there. So just be aware if you're looking through subgraphs that are not your own, look for that bind and try to get rid of those. And this kind of leads into, do we have control of the smart contract? Are we indexing a smart contract that we can design? Could we emit data on that smart contract and have it properly give us the data that we need? That would be ideal. So if we do have control of that smart contract, yes, have it be event data if possible. Now, if we do not have control of that smart contract, that's okay, because a new feature that I'm very excited to announce here, I think the first time publicly, is that we will soon, in the next literal day to 3 days to 5 days, be able to declare ETH calls in the manifest. And this is actually a sentence that I got from one of the GraphNode developers. If unable to avoid ETH calls, declare them in the manifest so GraphNode can perform them in parallel before handlers run, which minimizes total time spent in calls. Declared ETH calls. Declared calls are executed in parallel and cached in memory, allowing handlers to retrieve results from this cache rather than making actual RPC calls. So check that out. Update your CLI to have the most recent version, so spec version 1.2.0, and give this a try. Right now, I believe this is available in hosted service, which, funny enough, is sunsetting in a few days now. So get it while it's hot there. But this will soon be rolling out to Studio any day now and be able to be played with. So pretty cool news that we can actually declare these ETH calls in our subgraph.yaml. And from there, go ahead and optimize those ETH calls. Very cool stuff. So if we want to read more about avoiding ETH calls and ETH call management to just minimize their use as much as possible, check this blog out. This is by Simon Emanuel Schmid, who wrote this blog, and it's a solid deep dive into ETH calls and different strategies on managing them. So there will be more best practices. Stay tuned for those. This was 1 through 4. I'm working with between 5 and 10 people at any given time internally, just debating what these best practices might be, talking with many people on the GraphNode team, many different developers in EdgeNode squad, that we're trying to find the best way to get this information out there. So stay tuned for more. But for now, just use these if possible with your subgraphs. Tinker around with them, see what performance increases you can get with your subgraph, and make subgraphs on just optimized for you as much as possible. So that is quite exciting. Once again, this is the Graph Builders newsletter. If you haven't signed up just yet, I'll put this in chat. So you can sign up to this. I write this every single month for builders out there to really stay abreast of what's going on in the graph ecosystem. And thank you for your time out there today. I'm really happy to be giving a high-level overview of this. There will be a second segment, like I said, with the GraphNode team. I'm trying to get that scheduled with them, and they will be here to go over these best practices and a little bit more technical detail about what specific performance increases can be expected with these changes. So with that all being said, and I'm wondering, are there any questions out there about subgraph best practices? Any questions whatsoever? Fair enough. All right. Well, thank you everybody for coming to the Graph Builders office hours on May 23rd, 2024. Stay tuned for next week's Graph Builders office hours, where we'll be having members from the Semiotic team talking about some AI cool stuff that's coming down the pipeline for them. So thank you everyone for joining, and good luck with those best practices. Bye.